My name is Peyton Wood, and
I'm James Hoyt.
this is our project that we decided to make for our artistic electrical art project. And what we had in mind was a lighthouse because the criteria that it had to follow was to have a light source, sound, as well as a moving mechanism that was inside of your electronic art design project. So we did just a standard lighthouse, and within here you have a LED that's controlled by a 3-volt watch battery. And you turn it on. There's the light. Place it in there. Put the cap back on. And then he'll play ocean noises. Yep. And then as you can see, after I flick this master switch up, the lighthouse will spin. Waves will crash. And you have the fire coming out on the ship. And it may look, there's reference here. So the one thing we did struggle with the most had to be the placement of the LED for that lighthouse, because whenever we were trying to find the placement, we were like, oh, we could have a wire that could run straight down. But then it also would interfere with how that LED would sit on the plate, so then it would wrap itself around the motor and then pull itself out. So what we decided to do was, like I said, that 3-volt watch battery that we have in there, so that way it's still able to keep it. I had to 3D print these 3 components. There's one very thin piece of clear tubing right here. You have a 3D printed plate of which the LED sits on, and then you have a 3D printed cap for just for it to look nice. Overall, I think it turned out really good. I like the LEDs and the fire to make it where it looks like the flames are actually flickering inside of it. And yeah, that's the project. Do you have any words? Nope. Yes, we can show you the back. So, made it to where you could purposely see inside. And there's our circuit right here. That's connecting to your LED. That's going to the boat. And then you have your motor that's just connected and hooked up to your master switch. That's going through here. The motor is sitting right there. It's a 30 RPM motor, so it's making 1 revolution per, no, 2 per second. My bad. We have to had it connected to we had to jump cables to make it to where it was 12 volts to be able to power an LED strip to inside of that ship. Otherwise, we found out that it wasn't going to be able to get powered by a regular standard 9-volt D battery. That's pretty much it.
My name is Ian Fisher.
And I'm Blaze Fauché.
And we decided on a duck in a swamp setting. The way we came up with this idea, I was originally in engineering second, so PM, and there Sage and I wanted to do a pterodactyl, so a pterodactyl type of animatronic, but I moved over here and I joined Blaze and Jacob, which isn't here with us today, and they're duck hunters, so we decided to agree on making a duck animatronic. So that's what we have here. We have the duck, which you'll see it move in a minute. We also have LED strips under here to make this turn blue, like water, and we have fans right here to make the leaves act as though they're being affected by the wind, as well as a little campfire here, which is sort of out of scale, but was thrown in there last minute. And of course, we have sound and everything else that they have as well. Later, when you come by, there's a little demonstration of the mechanism that's making this thing move, since you can't see it right now. But I'm going to go ahead and set it up. So after a while, if you watch the duck, you'll notice that it'll become a little bit off-centered due to the fact that these motors, it uses 2 motors, 1 for each wing. Here, let me turn this down a little bit here. And they are slightly off. They don't go the same speed, so as one rotates, another one kind of gets a little off-center, so one of the wings will start flapping a little off than the other one. All of these small parts are 3D printed and designed by me, and all the artwork and all this stuff was crafted by Blaze and Jacob. So yeah, you got anything to say? We do have simple circuitry. We have 2 6-volt batteries, which we have lined up in series to create 12 volts. We have the fan blowing off of 12 volts. We have the duck motors going off of 6 volts. And we have the LED strips also going off of 12 volts as well. We have our campfire flickering using the 555 timer, which they are also using for their flickering with the flames. And everything else is pretty self-explanatory. This mechanism is just for one wing, so it's a push-pull mechanism. So as this little turntable goes around, it basically pushes these levers up and down based on where it's going. So this is in each of the wings. So we have one of these in each of the wings. So that's our mechanism.
All right, how about that, everyone? So my name is Ryan. This is Samantha. And for our project, we chose to do kind of a place setting. We went through a few ideas, but we decided to do this one because we thought it'd be really unique and really different from a few other people's. You know, everybody was just great, but we kind of want to stand out a little bit. In ours, and I'll show how it works in a minute, we had one thing moving, and initially we were going to have the curtains opening because we thought that'd be really cool and unique. But we figured out pretty late on in our project that was kind of difficult to achieve. We went through a few different phases and a few different trial and error to try and get it to open. And eventually we got it to move, but it wouldn't quite open the way we wanted it to. And there was just a lot of problems with it. And we decided yesterday, actually, that we weren't going to do that. And so we ended up deciding on putting some stars that were, you're going to see in a moment, move. And accompany the lights down here, which is kind of hard to see, but there's lights up here at the top to kind of show setting the stage and setting the kind of environment and everything. And my partner Sam, she made all the people inside and the name and everything like that. So without further ado, do you mind putting the music on and we'll demonstrate? So as you see, we have 2 motors on both sides. It's kind of loud. We have 2 motors on both sides that are causing the stars to spin. If you look down, there's lights right here flickering. Just like every other team, we use a 555 timer to achieve those lights flickering. They change in about 1 second, each second they switch over. And so there's not too much to say, but yeah, and if I can show you guys kind of how the circuit works on the back. Turn it around. So it's kind of crazy, kind of haywire, but we have our circuit right here for the lights back there, with just a few different things that causes those lights to turn on and off. And then we have another circuit kind of connecting on this side, the switch and connecting everything together. So we have that circuit for the lights specifically, and then we have another circuit over towards the left for everything to connect. And we have a 6-volt battery right there. So that's our project.
So we created a museum project. We call it the Engineering Team Museum. We have portraits of all the pictures that we took in class of like us doing projects, such as like the bridge project or like gas laws. We also have one from a field trip of all of us. And basically, this middle part, we have a two-sided portrait that is on a motor that turns. And then we also have behind these portraits is LED lights that we're supposed to light up like one at a time in sequence. And our music was gonna be just like museum music, and we have the speaker down here. And yeah, it's pretty much it for the design. For the circuit underneath, can you flip it? For the circuit underneath, we basically created a daisy chain timer, which is like 4, 5, 5, 5 timers in sequence, and they're all connected to each other, which results in the LED lights lighting up one at a time. And we have all of it. We have our breadboard, which is our circuit. Then we have our speaker up here, and we have our motor in the middle.
Hi everyone, I'm Jamilio, this is Caden, and our project is like a dragon that we're gonna make, or that's inside of like a cave. We had to do a lot of planning and a lot of testing for this. It was just, we all had to focus on our like the learning of the electronics and all that, and it took about 2 weeks, like he said, and right now we just get to show y'all like what we pretty much have made. And if I turn this on, then I press the reset, we do that. We just have a little dragon in like a little cave setting, and we have a little speaker hook up to it, to the computer, to get the sound effects. We have the lights at the front, you can see, there you go. They like blink in succession. We also have the lights on the little, like the mine part. And there's a lot of planning that went into this and just setting up the lights properly. And thank y'all for letting us present to y'all. Anything to say?
No.
I'm Macy and this is Patrick. So we wanted to do like a police chase kind of theme. If you can't tell, that's Highway 90 Booty, where there's all kind of cops. If you drive around there, then you know. So we're kind of doing where a car is getting like pulled over. I'll turn on the... Yeah, and that's it.
The circuit was very hard to complete. It took a lot of batteries that didn't catch on fire. We had 2 or 3 batteries that like had smoke coming out of them, and yeah, the circuit was just like not working yesterday, and it finally worked.
Yeah, we also had to 3D print a part to go onto the motor here, and it was a lot of trial and error, so it took like 2 days for me to come up with the dimensions that it had to be to fit on the motor. So we kind of didn't put all this together until like 2 days ago because of all the work that had to go into it. So
I'm Mason, and this is Steven. And what we did was kind of like a cartoonish robot, and we're just going to turn him on and show you what he does. So we have his eyes light up, and we have an antenna on the top that's blinking yellow. And we also have this tube, which has a fan and a motor, and it just blows air and shoots out whatever we put. Yeah. think the most difficult thing was setting up this right here. It was kind of hard to find something that was going to shoot properly out of it.
It's like a fan, and it's just a regular motor, regular DC motor.
Yeah.
My name is Skylar. This is Sage. We did kind of like a grand performance kind of thing with a piano. And so here's our little stage with our piano, and here's our metronome. We turn on that, and it has a little clicking, has lights on the bottom. And then here's our metronome. And then so that's about it. It turns on lights, keeps time, and then the metronome just moves back and forth, and we have our speaker playing music. So that's about it. We went through a lot of LEDs. I burnt out a lot of lights, and then I realized we had to use resistors. And then a lot of wiring went into the bottom of the stage, and there's just a lot of just wiring everywhere. So it was mainly wiring. So here, it's kind of just, we have the battery to a switch, and then the switch powers this breadboard, and the breadboard has the light and the motor. So this one's way more simple than this. This one we have a 555 timer to time the entire breadboard, and then that's connected to the LEDs, and then we have it connected to the switch. So it keeps time.
We have the battery is in the back behind all this, and then it's connected to this circuit which controls everything. Then we have the switches and the buttons that controls things. Yeah, this is the speaker that plays the sound. And I have it connected to my phone for the sound, where we got the sound from.
This was the speaker, and we had to wire it up completely separate from the batteries in this circuit because of the type of speaker that it is. So for our circuit, this is kind of like the on and off kind of switch, but it's connected to an I-55 timer, which is kind of like a timing circuit, and there's all kind of like different components inside of the little chip. And then over here is like our timing part with resistors and capacitors, and then it's connected to a relay because the motor has to be ran by a 6-volt battery, and the I-55 couldn't run it on its own, so we had to use a relay. Then we also had to connect it and chain it to this I-55, which is connected to the LED lights, and since the LED lights needed 12 volts, we also had to use another relay, and we had to make sure that we sent 12 volts to this one and 6 volts to this one.
Whenever we were doing the batteries, hooking up the batteries, we needed 12 volts for the LEDs, but the speaker was only 6 volts. And so whenever we hooked up the speakers to the actual batteries, that's whenever everything caught on fire. Well, not on fire, like on smoke. And then Macy I was looking at the speaker and trying to see everything, like make sure it's okay. And then Macy just sees the battery smoking. She's like, turn it off, turn it off. And so.
But yeah. we got to figure it out.
Yeah, because it's important that you're making sure you're only sending the amount of volts that it can take, because if it's too much, then it'll burn out.
So for ours, all the guts is just right here. It's a very big mess in there, but because we got to fit everything on one breadboard, and everything's run off of 2 6-volt batteries, which powers the speaker, the lights, and the motor. And we used 4 I-55 timers to get them all in sequence. And yeah, I think it took us a week and a half to actually get it to work.
It's a lot of trial and error. More error than trial.
Definitely. In the end, it worked. So. Okay. All right. Thank you, everyone, for
for joining us. Like I said, if you want to hang around and come to speak to our team members and ask them questions and maybe find out a little bit more about what they went through with these projects. Thank you for coming. It was a project where they're learning, the unit is about electricity, magnetism, electromagnetism, and that's the physics, and then the engineering is electric circuits, electronic circuits, integrated circuits, and so on. And the project, the Electric Art project, is at the end where they take what they learned and apply it to building something that's an electric art form. And the requirements are that it has to have a motor, it has to have motion of some sort, it's got to have a timing circuit so things turn on and off automatically, of course it's got to have lights, and it's got to have sound. And then the rest of it, of course, is up to them, their artistic ingenuity. And if you see these projects, you see that all the teams come up with something different, something really neat. But every one of them applied, those requirements for electricity and electronics.
Because we had different ideas. Initially, we were gonna, or I at least, offer to do a play that goes wrong, which is a production Hanville's putting on right now. And I'm in that play, so I thought, oh, we can make a theater, and then we can do that play. But then she wanted to do kind of a park scene, and so I was like, I think that'd be a more unique idea to do. And so I guess I kind of learned to be able to lay down some ideas that you might want to do the most and say, you know what, no, I think it'd be cooler if you combined others' ideas and actually make something that's more unique, because it's not just one person doing something, but it's two people coming together and using their thoughts and their ideas.
We were just thinking calm and peaceful theme, so piano, a good background, and when you're playing the piano, you have a metronome usually, so that's putting our ideas together, and things made it easy because we have different ideas and different thoughts about how to do things. So coming together and combining that made everything easier, the decorating and the circuits.
So as we went along, I was teaching them and guiding them on all these different ways of designing circuits to do things. But then at the end, in this project, it was, okay, now it's up to them. And I pretty much just leave it up to them. Now, of course, they have questions as they go along. If they're having a problem with something, why isn't this working or why isn't that working? And it may be a detail that we didn't cover in the theory, so I can get into that for them. But for the most part, they're taking what they learned during that unit and applying it to this project. And like I said, it's as much as possible, it's hands-off for me. It's okay, take what you learn and try to do something with it.
The hardest part was probably, I want to say the time frame we had. Even though we had a good amount of time, we had about a week to really get everything situated for the idea that we wanted to put together with. Initially, we had the idea of opening curtains, but that idea felt kind of slim. Initially, we thought we had a lot of time to work on everything, but once we started putting everything together, we had to kind of start problem shooting and problem solving different things that we didn't realize we didn't fully understand how to work out yet. And so it was really just a time frame of being able to get a project that we're satisfied with, we're happy with, and that we kind of came up with together in the time frame that we were given. I think was probably the hardest part.
Engineering is applied science. So they learn the physics because they're also getting credit for physics. The physics is electricity, magnetism, all the Faraday's law and so on, all those basic concepts. But then the electric circuits and making them work, that's engineering. That's where they take the science. That's what an engineer does. An engineer has to be a physicist first, and then what an engineer does is apply the science to solving problems, to solving real problems in the world. And then this project becomes a problem for them to solve. They have to design, and then as they're designing, they find out that things don't work, and so they have to redesign until they get everything working the way they want it to. The other thing about the project-based learning is they're having to work as teams, and in the real world of engineering, engineers have to work together as teams, so they do that.
My most favorite part was decorating, because it just allowed you to be creative and design what you wanted to.
I think my favorite part of working on this project was really working with the lights. I think was the coolest part for me, at least, because that's really where the circuit was, because it's, it looks cool on the outside, but if we turn it around and we show the inside, there's all the wires and all the electrical part to it, and the lights were definitely the more complicated circuit that we had to come up with. I think that was the most fun, the most enjoyable part, really designing a circuit yourself then building that circuit, putting it together, and then seeing it function the way that you designed it to function was really exciting. I knew a little bit about electricity. I took a class at my high school, Hahnville, but really to be able to design a circuit like I just said, that was really something I never learned. I never knew how circuits worked in total. I didn't really fully understand how electricity worked and how to really kind of make it bend to your will in the way. So really to be able to design something and work with different components like capacitors and resistors and LED lights and 555 timers, different things like that, elements like that. That was really exciting, and it also helped me understand what type of engineering I wanted to go into, what I really do enjoy. So I think really just understanding electricity and working with electricity and seeing how it functions and how you can make it function how you want it to function was probably the hardest, but the most exciting part.
Coming into this project, I didn't really know how to build a circuit or know anything about circuits at all. But before we do the project, we do lectures and learning about all the different things that goes into this type of stuff, and like actually doing labs and stuff to get hands-on experience with it allows the project to be easier.
It's fantastic to me. I mean, I'm so proud and of these students, but for me, it's so satisfying to see when they came in. Essentially, none of them knew anything about electricity. And we're only talking about a few weeks ago. And in this time, they've learned so much. Not only learn, like I said, about the theory, but you can see now they're using it. They're not only able to tell you and work problems and tell you how this stuff works, but they can actually build something, design something, build it, and make it work. So just that, what gets me is the fact that this is happening over just a few weeks. To me, that's fantastic. And they, in the end, they're rushing to finish this up. Like I said, even just before the show started, they were still working on their project, finishing things up. So that's another thing. As far as project-based learning, we're trying to give them a feel what it's like in the real world, and it works. Because even things like those time pressures and all, that's what happens on the job to engineers that are, they have to meet deadlines and so, and they get to sense that and work through it, and in the end, they're successful. And to me, there's a lot of satisfaction in that when you're pushing and things don't seem to be working and you don't know if you're going to make it, and then in the end, it works. So to me, it reminds me of me on the job and some of the things I saw. But now I get to see it here, and it's just a lot of fun. Like I said, a lot of satisfaction. It's wonderful.
This is all just really fun, just experimenting and making projects.